Good evening, everyone. Welcome to the Center for Innovation and Precision Eye Health monthly webinar session. I'm Yi Chong. I'm the host for today's webinar session, and let me introduce myself a little bit first. I'm an assistant professor at the Yong Yulin School of Medicine, National University of Singapore. I'm also the co-lead for Population Data Science at the Center for Innovation and Precision Eye Health. And today we have with us Dr. Faris Antaki, and he'll be sharing a very interesting topic on large language model in ophthalmology. And after his talk, we will also have an interactive panel discussion with two of my colleagues, Assistant Professor Tianbo Liu and Assistant Professor Marcus Tan, who are faculty members in National University of Singapore. So before we formally begin, let me say a few words about Faris first. Faris is a good friend and a good collaborator. And he's actually a retina specialist by training. He's originally from Montreal, Canada. He's currently a scientist and a fellow at the Morpheus University of College of London, Institute of Ophthalmology in London. So he has published numerous papers, articles, and received multiple research and teaching awards. And the past 18 months or so, he has been very active in the space of AI, virtual reality, and of course, large language models. And some of you may have read his papers, which have been published in multiple eye journals. So without further ado, I shall hand the stage over to Faris, and I look forward to his wonderful talk. Faris, over to you. Thank you.
Thank you so much, Yi Chung, for the kind invitation to speak today at the National University of Singapore. I think we're both been fascinated by this technology, and I look forward to our collaborations in the future. So without further ado, I'll share my screen with you. All right, please confirm you see my screen and you can hear me well. Fantastic.
Yep.
So the topic of today's presentation is large language models. And before we get into the topic, we were interested to see how much you use language models in your everyday life. Do you think LLMs have the potential to reduce the workload of ophthalmologists? And do you think we will start using LLMs in routine clinical care in the next 3 years? So I'll invite each and every one of you, if you see the poll in front of you, to answer. So we'll wait a few seconds to get your responses, and I'll comment on them before we start the presentation. So I think let's see the results. So actually, most of you do not use large language models in your routine life. Most of you do believe that language models can be effective at reducing the workload of ophthalmologists. And most of you believe that we will start using large language models in clinical care in the next 3 years, which are interesting trends. I think for the first question, I would have thought that more people would use language models in their everyday life. So let's close the results and then get into the meat of the topic. So traditionally, to build machine learning models and deep learning models, we would require vast amounts of labeled data. We would need a set of labeled data to train a specific model for a specific task. And if we were interested in doing multiple tasks and solving multiple problems, we would need to train different models and have different sets of labeled data. Now, foundation models are a novel paradigm for building AI systems. So instead of building those different models, we build a foundation model that is trained on large amounts of unlabeled data, and with small amounts of labeled data, we can then fine-tune or adapt the model to do a variety of downstream tasks. Foundation models can be made for language, for vision, or for both. You're probably very familiar with foundation models for language, which are large language models. Large language models are a type of foundation models that are made for language. The goal of those models is to generate text responses in natural language that mimic the way we speak as humans. So they're trained on very large corpora of archives from the internet, millions of books, as well as encyclopedias. And some evidence shows that probably those big companies have even transcribed YouTube videos to train those models. A simple way to understand how they work, let us take this simple example. A quote by Heraclitus, a Greek philosopher, that says, "The only constant in life is change." That text is tokenized, so split into different parts of text, small vectors that can be words, can be parts of words, can be letters. In this case, it happens to be that there are different words, and one of the token is masked. So let's say the word change, and then we train a model to predict that word, that next word. If the model predicts the word growth, that may be a correct answer, but the model has to adjust its parameter until it predicts the word change. And those models, through a concept called attention, are capable of handling sequences of text in a way to understand the context of each word by considering its relation to all words around it. And effectively, if you do that at scale using billions and billions of words, then LLMs can effectively learn how we write and how we speak. But how we write and how we speak, particularly in the vast and anonymous world of the internet, will frequently contain inaccuracies and errors. And more concerning, it may contain themes of discrimination and hate speech. So before you use a language model, those big companies try to align the LLMs to our values. I mean, it is quite difficult to determine what the common global values we all have as humans. But what we really want from LLMs, I think we can agree on. We want them to be helpful, we want them to be honest, and we want them to be harmless. There are many ways to make LLMs helpful, honest, and harmless, but one popular way is reinforcement learning from human feedback, which is the technique used by OpenAI. From my understanding of how that technique works, and in a high level explanation, is you have inputs that go into the language model, the LLM produces an output, and that output is evaluated by humans. Those humans, ideally, you want a group of humans that are diverse, that speak multiple languages, that have different levels of instruction. They evaluate those answers, and then you train a reward model to feedback into the LLM, and that loop is repeated until you're happy with the LLM outputs. In medicine, when we talk about LLMs, we need to evaluate the responses of LLMs in a holistic manner. So beyond just simple accuracy, is the answer good or not good? Does it do well on multiple choice exams? What is the numeric performance? We must also look at things like the presence of incorrect information, the agreement with scientific consensus, the emission of content, the extent and likelihood of harm, and the possibility of bias. This evaluation framework has been described in seminal work by Karen Singal and the Google team, and that was published in Nature in 2023. And that same paper showed really impressive results for language models. So they describe MedPalm at the time, which shows significant improvements over past models that were 2022 and before, that scored 67.6% on the MetQA, and I think that model they described scored in the 80s. And just very recently, that progress is accelerating. So we go from MetPalm at 67.2, MetPalm 2, 86.5, GPT-4 at 90.2, and then MedGemini at 91.1. Now, when we talk about all those different models, they're not always completely new models. Sometimes you take general models, like in the case of MedGemini that was published very recently, but then you have to make adaptations and specialize them to medicine. And the way they created MedGemini is by including things like self-training with web search integration. So the model would search on the internet and improve itself. It would be fine-tuned, so adapted to the domain of medicine, and then they would instruct the model to do chain of reasoning, so to think about its answers before it answers. Obviously, the topic of our presentation today is LLMs in ophthalmology, and we've seen many papers looking at LLMs in ophthalmology. We may have been one of the first to talk about that topic. That paper was published in January and in 2023 in Ophthalmology Science, where we took two large data sets of multiple choice exam questions that people use to practice for their boards in North America. This is how the question would look like and how the responses would look like. We evaluated the models on their ability to pick a correct answer from four possible answers. And at the time, in the two question banks, the BCSC, which we licensed from the American Academy of Ophthalmology, and Ophtho Questions, the performance was around 50%. Not great, but it was very reassuring because the accuracy was dependent on difficulty index. So the difficulty index was the percent correct by humans. So the harder the questions were, the more difficulty or trouble GPT 3.5 had. And then we tested GPT-4, and that work was published in the BJO. We took those same question banks, the exact same questions, and on the exact same question set, GPT-4 performed significantly better. And if you look on the right, we show you GPT 3.5 in purple, GPT-4 in yellow, and almost in every single subspecialty, the performance was increased and often statistically significantly increased. We also show you human performance in gray. And what was really interesting is that the performance of GPT-4 was superior numerically to historical human performance, but it was not statistically significant. We do argue in the paper that we have to be really careful when we try to say that a GPT model is better than humans at answering questions, because we shouldn't only look, as I said, at numeric performance, but also at the quality of those answers. And I want to add to that is that clinicians today, whether optometrists, ophthalmologists, general doctors, have way more qualities that we should look for, such as empathy, ability to communicate, that today may be lacking in some language models, although we've seen some evidence of empathy in medicine by some language models. I want to point out to a review published in the BJO by the team here at the National University of Singapore that really summarized very nicely the emerging trends in LLMs in ophthalmology. And one of the conclusions was that LLMs have a transformative potential, and I think all of us agree on that, but that future research should focus on two things: standardized evaluation frameworks, and then image-based data and multimodality. So let's focus on the first point. So one thing I've learned is that evaluating LLMs in general is a minefield. It is really difficult because all the answers we get are highly dependent on the prompt we use. For example, we can tell the model you are an expert ophthalmologist, and then we improve the performance. On model temperature, so the creative ability of the model that we can adjust when we use the API or the programming interface of the model. And then the model version, the training cutoff date. So some models stop training in 2021, some in 2023. So we must communicate all those parameters when we're publishing papers on LLMs. I want to talk now about prompt engineering. So this ability to tell the model, to set the scene for the model. We published a recent paper in the British Journal of Ophthalmology looking at 422 complex cases of JAMA ophthalmology. Those are really complex cases that have a title, there's a case description, there's a figure description. Then you should, bring an open-ended diagnosis, and then you can answer one of four options of what would you do next. We tested the model using zero-shot prompting. So zero-shot means we don't tell the model, we don't give it examples. We just instruct it to do, to set the scene. And what we get is it scores really well, 40% in open-ended diagnosis, which, those are challenging cases. And then it scores 60% at determining the next step, which is a multiple choice question. But when we do something called zero-shot plan and solve, which is a technique that's been described by other authors, and I copy pasted here, so you have the original prompt, then you ask the model to carry out a plan, to reason step by step, to be careful at common sense and logical coherence, then the model does better. So we get a significant improvement in the diagnosis, and then just a numeric superiority in the next step. And so this was a really interesting finding because for the same model with different prompts, you get different results. The other thing is model temperature. Going back to our paper in the BJO, we took GPT-4 at different temperatures. So a temperature of 0 is that the model is deterministic. It provides perhaps shorter answers that resemble more closely the training data. Now, a probabilistic model, which is at the extreme, 1 or even more, then there is more entropy, more randomness in the answer. And we find that there's no significant difference in the performance on multiple choice. But when we ask clinicians to rate those answers, what do they prefer? Well, they generally find that 0.3, 0.7, and 1 are preferred to 0. So they prefer more creative answers to more deterministic answers. Some of the noted reasons is that the answers are longer, provide a little bit more feedback and educational value compared to GPT-4 zero responses. Now, the other thing I want to talk about is study design, and this is important. So we're doing all those things, we're prompting, we're testing different model temperatures, but how are we evaluating those answers? Again, I point out to work done by Yichang and his team, published in a journal by the Lancet group, that showed that GPT-4 delivers accurate and comprehensive responses to myopia-related queries. That conclusion is really good, but I think one of the more nice things about this paper is the methodology. So there's a very nice design of testing multiple LLMs and then concealing the features that identify the LLMs and asking 3 experienced pediatric ophthalmologists to evaluate those responses. They ask them to grade the answers multiple times with a washout period, which gives us really robust and clean, evaluation of the answers of the LLMs. And what was really nice about this paper as well is that they not only graded the responses on accuracy, but they gave the LLM a chance. If the LLM response was poor, they asked it to self-refine, to regrade itself, and to correct. And we're seeing more and more evidence that doing self-refinement of the LLM to look at its own answers allows us to have better responses. Now, going back to the review paper in the BJO, the other thing that that paper highlighted is that maybe we should also be looking at multimodality. And LLMs with vision capabilities are also called vision language models. Vision language models, I think, have most potential in ophthalmology because this is inherently how we practice medicine. We rely on patient histories, but we also want to include multimodal inputs such as OCT, fundus photographs, ultrasounds, MRIs, anterior segment exams. So ideally, you want to provide a vision language model with interleaved inputs, which are a mix of language and then images. And ideally in the future video, you get a response and you want to be able to do visual question answering. So the clinician might be interested to ask very specific questions. What is this patient's risk of converting to wet AMD? What is this patient's risk of cardiovascular disease if we're thinking of oculomics or this ability to connect the back of the eye, the retina, to systemic health? That would be the holy grail. We have been interested in testing vision language models in retinal disease. And I point you here to a brief report we published recently in JAMA Ophthalmology, where we tested Gemini Pro at giving us structured responses to see if it's able to detect things like outer retinal atrophy, subretinal hyperreflective material, drusen, macular hole, epiretinal membrane. Really, perhaps somehow complex but important features to detect on an OCT that experts are able to do. And unfortunately, that generalist vision language model failed miserably. The F1 score, which is a harmonic mean and of recall and precision, showed that the performance was 10.7%, very low. And we conclude that those generalist VLMs have limited capability in doing feature detection for OCT. And that brings me to say that those models have really good language capabilities, but perhaps not as good vision capabilities for the time being. And maybe we should leverage other foundation models that have proven strong vision language capabilities. Here at UCL, the team has developed RetFound, which is the first foundation model for ophthalmology. It is self-supervised training. It is open source, and it was trained on 1.6 million images and has the ability to do a variety of downstream tasks, beating state of the art at ocular disease diagnosis, ocular disease prognosis, as well as oculomics. So if we were to find a way to combine those language capabilities of general language models and the bespoke vision capabilities of models we train on ophthalmic data, that would be the ideal solution. One way to think about that, and here I show one way to train such a pipeline is CLIP. We would have image text pairs where we have a description of an image and the image itself. And then those image text pairs would be, the text and the image would be processed by an encoder to generate feature embeddings representative of the images and text. A vision language model would be trained to maximize the agreement between those image and text feature embeddings. And this way we could train a VLM for ophthalmology. But then this begs the question, where do we get image text pairs? In radiology, it is very commonplace, of course, it is the standard of care to write a report every time we obtain an image. But in most places I've worked, we don't routinely write a report when we look at an OCT. I know there's been some recent evidence, I think, coming from Hong Kong at doing a vision language model for fluorescein angiography. So this is really, really encouraging. Now, let's go back and talk about potential use cases of LLMs in ophthalmology, because at the end of the day, we're doing all of this to hopefully benefit patients. So we have to think of the downstream tasks we want to achieve. I point you to a very nice paper published again by Yi Chung and colleagues in the Lancet Digital Health. And from that, I adapt three categories of potential uses. Workflow improvement, so using LLMs to help us with documentation in the electronic health record and to write reports, to help us with decision making, so building decision making and triage agents. And then finally, to talk about medical education. Can we use a language model to simulate a virtual patient and to give us summaries of evidence? The first one is really nice. We would need large multimodal models, which are models that are able to listen, record, transcribe, and then write a clinical note in the electronic health record, and then translate that complex note into a simplified patient summary. We can use language models for medical education, and we touched on that recently in a review we published in the BJO, where looking online, I've seen a lot of people put online custom GPTs claiming they can be useful for ophthalmic education. So we wanted to provide a framework in that paper about those. So by using custom GPTs, which is a service provided by OpenAI, but there are many, you can create your own GPTs with custom instructions and provide predetermined knowledge to create tools for your own self. We, in that paper, talk about those frameworks. We also talk about the limitations, and we introduce as examples three possible GPTs. One is called iTeacher, that generates questions from clinical guidelines to facilitate learning. And this idea was inspired by Yi Chung's work. Eye Assistant, which responds to various physician queries based on guidelines. And one of my favorites is the GPT-4 GA that summarizes geographic atrophy trials based on peer-reviewed literature. Those are all examples, and they're very niche topics, but feel free to go and try and use them to your own benefit. But ideally, what I think we want to get to is to use vision language models as smart triage agents. So we could have a patient send a photo, describe their symptom. The vision language model answers with a follow-up question, confirming here that the vision is good and providing an appointment the next day for this patient. Now, all of this is nice, but what I think we've been doing so far is we've been using LLMs as a source of memorized information. So we have a user prompt, we ask a question to what I like to call an inactive LLM. We test its ophthalmology knowledge, which is likely extremely small compared to its overall knowledge, and then we get a response. And then we evaluate those responses and we talk about temperature and all of the things I mentioned before. But instead, and maybe the only takeaway message I'd like all of you to go home with today is let us think of LLMs as reasoning engines and smart agents. So instead, we have a user prompt. We can have a generalist LLM, for example, that is active. We design workflows for those LLMs and give them the ability to do retrieval augmented generation. So go and check their answers on vetted ophthalmology knowledge, go to use certain tools to do code generation, data visualization, web search. And all of that is done through reflection and planning within the LLM itself by prompt engineering it to do so. And this way we can get aligned responses that are more useful to us. And that can be done with a generalist LLM, which is open to everyone, or a fine-tuned LLM, which is an LLM that you adapt its parameters for your specific needs, such as ophthalmology. This brings me to how do you customize LLMs? Well, there are multiple ways. You can do so with fine-tuning, which is a supervised learning approach where you need to have a labeled data set that can be big or small, that is debatable, but you need to have really good vetted question answer pairs. Fine-tuning changes the parameters of the language model, but if you don't want to change the parameters of the language model, you can do instruction tuning or prompt engineering, where you guide the model behavior. You set the scene. You tell the model you are an expert ophthalmologist, or of course, you can use more advanced prompt to ask the LLM to reason before it gives an answer. And then, of course, you can do what is really, really interesting, which is retrieval augmented generation, or RAG, where those models go and have the ability to extract information from documents that you provide that are validated, such as guidelines. And before yesterday, that would have been my last slide, and that would have been my conclusion, to say that the future is bright and this is only the beginning. And I wanted to share with you a caveat that everything we've done so far is not timeless, because the models continue to evolve, and any performance paper we've published, in my opinion, almost becomes obsolete as soon as it is published. But what we learn from those models is best practices to doing LLM research, ways to analyze the results, and ways to do bigger and better things. And there's no better way than trying and experimenting with those models. So this was going to be my last slide, but OpenAI yesterday released GPT-4o Omni, which is supposed to be their new model that has enhanced capabilities at multimodality, at vision and speech. And that begs the question is, how do we keep up with the progress in the world of LLMs? Are we going to keep chasing the best performing model to then say, this is the model we want to test, and let's design really nice studies like randomized trials to test the real benefit of those LLMs? When do we decide that? When do we decide this model is good enough? Because ideally, what we want to do is go from papers to the clinic and to the benefit of patients. And since the progress has been very fast and very quick, I'm still perplexed about which should we wait until we have better models and when to do really big studies, RCTs, prospective studies demonstrating, superiority of LLMs, or should we do with the models we have today? And that really brings me now to my actual conclusion to say the future is bright and this is only the beginning. Thank you so much. I'm happy to take any questions, and I'm really excited to connect with all of you. So feel free to write to me. My email is on the website, and you can tweet at me or talk to me on LinkedIn.
Excellent. Thanks very much, Ferris. Thank you. Ferris, if you don't mind, would you like to share the last slide? I believe a lot of the audience would like to connect with you either via email or LinkedIn. So maybe you can share the last slide again. Wonderful talk, wonderful talk. And you definitely did not disappoint. And I just want to make a note that actually Ferris and I, we met last week at ARVO in Seattle, and we were already talking a lot of ideas on large language model, but little did we know or expected that the GPT-4 Omni would come out, and it just came out yesterday out of nowhere. So it just shows that you can never be fully prepared, and things are really moving fast. But I like what Ferris alluded towards the end, which is despite how fast and rapid the field is moving, we still need to keep up, and we need to still find the best way to evaluate. And at some point, we do have to perform trials to best determine the evidence, which tools we should use to improve clinical care. So I totally agree with that. Now we shall start the panel discussion. And before we formally begin the panel discussion, I'd like to introduce our two panelists, Assistant Professor Dianbo Liu, who is also a NLP expert and a machine learning expert. So very happy to have him joining us. He's a faculty at the Yong Yulin School of Medicine, National University of Singapore, and as well as Assistant Professor Marcus Tan. Himself is a glaucoma specialist and also the Deputy Group Chief Technology Officer, and very well versed with AI tools, of course, large language models as well. So welcome, Dianbo, Marcus. Thanks very much for joining us. I think questions are slowly coming through, but maybe I'll let Marcus to kickstart with the first question, or even Dianbo, or any thoughts after hearing this wonderful talk from Ferris.
Hi, Ferris and Yizhong. Congratulations on the fantastic presentation. I think it's sorely needed, especially when this topic is often only presented in bits and pieces to the audience at times. I think you did a very comprehensive presentation covering all the way up to developments from yesterday. So I applaud you on that. Just to kick things off, I have a question. The questionnaire that you posted to all of us at the beginning. I'm curious as to the responses. Did you pose this questionnaire in UCL as well, or in more fields amongst the practicing ophthalmologists? And how were their responses like? Was it very different from what you had here?
Great question. To be honest, I have not, but I would suspect that it depends on the access to some of the LLMs and whether you're surrounded by friends who use them, whether you're in the field. So for me, it is. I am surprised when I see people not using LLMs on a daily basis, but the reality is, of course, my dad doesn't use it every day. My mom doesn't use it every day. My sister, but I do use it every day. So, or I'm often surprised they don't, because I see so much value in using LLMs in helping us in our daily routine. But I mean, those responses can vary by region, by what you specialize in, of course.
Great. I think that segues on to the point that basically, despite the rapid advancements that we see in LLM and in the literature, there still is a chasm, there's a gap between the deployment of such LLMs in clinical practice. That's what I see in ophthalmology as well, in Singapore and the region. So I think that may be something that we need to work towards as well. Thanks.
Yeah, so just to comment on that gap, a lot of people have been doing computer vision in ophthalmology for the last 10, 14 years, and we still have that gap. The number of, FDA approved models that, are able to do diabetic retinopathy screening is very limited compared to the amount of papers we see. So it is really difficult to, bridge that gap. And I don't see us bridging that gap in LLMs soon because we still need to learn about those tools.
Tim Ho?
Okay. Yeah. Thanks, Yizhong. So, Faris, it's a great talk. Thank you so much for sharing with us. So, I have a mixture of machine learning and the medical informatics background. So, I'm curious. Now, GPT-4o was published 2 days ago, actually. And if, as say, from the perspective of a patient, if we like to chat with GPT-4o or anything else, like a human manner, assume that machine learning model is a human, and assume this is between patients and a medical robot in a clinical setting. So what do you think is still needed to make the GPT-4o or any other models more like a human?
So I personally, the audio-visual capabilities of GPT-4o, I don't think they're available yet. They will be rolled out within the next week. But one thing the company has said is that it has made the models extremely fast and with very little latency, less than, normal human reaction. So I think that is really important to, if we want to have, realistic conversations between patients and medical, AI tools or robots, we need to have really low latency. Otherwise, it is not engaging. So I think OpenAI is on the way to solve this problem. The second thing is to have models that, as I said, be helpful, honest, and harmless. But then if you try to make the model extremely harmless, then it's not useful. So there is a balance to be that needs to be struck there. I know, for example, OpenAI has been doing what they call red teaming. So they have teams that evaluate those models for safety. But we have to, also be consistent in that is that what is helpful, honest, and harmless in San Francisco is not the same in Beijing, is not the same in the Middle East. So we have to be conscious of those geographic differences as well.
Yeah. A few weeks ago, we talked to some colleagues in the engineering or computing school. They are working with patients who are blind or partially blind. They are using some device to help them to see things. So the device convert the visual information into audio information. But in that case, you have to point out something. For example, see, imagine I'm blind. I need to ask my AI or my device, say, what's in front of me? What am I holding? So I think for this kind of task, the large language model potentially, in addition to the visual and audio understanding, it needs to have some sort of social cognition ability, such as what is me, so what is him, okay, my friend him, okay, what is I'm pointing to, those things. So do you see those kind of capacity will arise or emerge from simply scaling up the visual reasoning part of the large models, or do you think that should be something we can engineer into a system?
That's a great question. I think one of the issues with those vision language models is that they originally at least struggled with physics and understanding the relationships between items in the image. And I've tested that myself. Is if I want to, I put an OCT in GPT-4 and try to get some sort of description, it's not really able to count the number of PDs or drusen or things like that. So the ability to understand the world like we do is not there yet, I think. But the demos I've seen yesterday with GPT-4 Omni have been really, really impressive. Though it seems that by decreasing the latency and improving the model, they're able to get the model to react almost in real time to what's happening in the surrounding, to understand nuances between, interactions. If someone was being funny, if someone was being serious, to understand the scene very well. And to your point about, using those models with blind patients, yes. Again, this morning, OpenAI shared a video of, I think the company is called Be My Eyes, to use those language models for blind people and visually impaired people. And this is really changing, is going to change, I think, hopefully the life of many people who have visual impairment, because you can get really good quality description of the surrounding world.
Yeah. Thank you so much for answering. Merci.
Very good. Maybe we can start taking some questions from the audience, and I'd like just to add that maybe on a general note, for our audience, if you have not tried ChatGPT, well, feel free to give it a go, especially GPT-4 Omni, which was released yesterday. And guess what? The good news is it's actually free. Well, at least for now, it is free. And I tried out this morning. Actually, I do realize that it is faster. And in fact, I do foresee that such new capabilities eventually will replace conventional search engines. Say, for example, what Dr. Ferris mentioned, Be My Eyes for patients with vision impairment. They can easily use the voice to serve it as a prompt, feed it into GPT-4 Omni, and it will generate response to describe the surrounding and the context of the surrounding. So I think it is really a game changer. So on that note, let's move into something more eye specific now. Of course, there are two similar questions here. One is how this tool, large language model, how it will impact ophthalmology care, eye care practitioners, and in your mind, Ferris, which particular job scope or domain of our jobs can potentially be replaced by a large language model? And I would like to hear your thoughts on this.
I think most definitely help us with workflow improvement. So, particularly in North America, we spend tons of time documenting clinical notes for multiple reasons. I mean, clinical documentation is very important, but in some places we work in very litigious places where you can get sued. So you want to really document, perhaps sometimes defensively, what happened in the encounter. And if we have a multimodal model that is able to record the conversation, as long as it's stored privately and securely, and maybe transcribe it, that could be useful. The other thing, in that workflow improvement, if you're able to generate summaries for patients in language they understand and give it to them after every visit, I am convinced that giving patient ownership of their problem can significantly improve patient satisfaction, and also decrease, patient calls, for example, regarding their drops or their diagnosis. So it can be better for everyone.
Yeah, very good point, and I totally agree. And of course, all these things we need to evaluate. Of course, there's always low risk task and high risk task, and of course, we should always start with the lower risk ones. And one that Ferris mentioned very rightly is potentially, let's say, a discharge report rather than having a very formal written discharge report. And now with large language model being able to show high level of empathy and engaging language, maybe with that new form of discharge report, it will help to engage patients a little bit better and will cultivate better sense of self-discipline when it comes to managing their own health and eye health. So that would be one area as well. And so moving on, of course, I'll start with something more specific before I move on to more generic questions. One is, what do you think is the biggest gap in using large language model for medical diagnosis?
I think, we should not forget that large language models are software, and getting software to become a medical device is very complicated, takes a lot of time. And the other thing is, those models by nature are probabilistic. So you shouldn't expect them to give you the same answer consistently, even with the same input. So that is a major limitation. How can you be sure that a slightly different prompt from a patient will give, will still give a safe output? It is, in my opinion, almost impossible, to be sure. So we have to have ways to safeguard, those outputs before we can get to talking about the medical device.
Yeah, I think that's an excellent point. And again, it goes back to evaluation and evidence that comes up from evaluation. And Ferris just now showed one of his recent work published just about 2 weeks ago. Can check Gemini Pro, right? They can it read OCT scans? And the answer is can't really read OCT scans. And the F1 score, the accuracy is only like 10%. So they can't really provide good medical diagnosis. And at current stage, can't really do so. In the future, who knows? But at the end of the day, I think maybe very likely as an AI assistive tool, can't really be fully autonomous yet. I think that is the trend that we are observing. Um, and There's one question on RAG. The question is, for models which use RAG, they probably would they have copyright concerns? And are there any options to bypass these issues?
I mean, absolutely. I think the question of copyright is very important, because let's not forget that all of those work represent hours and hours and perhaps funding from governmental agencies that allow you to do this research and publish it. And then if it's used to train a model or used as RAG, then there has to be some sort of retribution to those efforts. It is really still not clear how we do that. And I think we're going to learn a lot by the lawsuit between the New York Times and OpenAI. And I think it's going to it's going to give us jurisprudence on how we should do things in the future in terms of copyright and training LLMs.
Yeah, that's excellent. Totally agree. And the next question, probably I'll direct to Marcus, given your role in the technology office. The question is this: as someone, for anyone who has interest in machine learning or AI, but hasn't really tried out large language model yet at the moment, what is your advice on how they can upskill themselves?
Okay, that's a nice question, I think. So, I mean, in the past 5 or 10 years, we've been seeing the rise of, modular courses that really show how we are moving away from traditional education. You no longer need, a full degree in software engineering to be a software engineer. You can pick and choose online courses, Udemy, Coursera, and these are widely available to, the general public. So I think with that, you can go at your own pace. I understand, even some of the Ivy League universities have their own online courses, which are modular in nature. And, having that, you can go at your own pace and explore. And I think that's a good way to get a good sense of whether, you really like this field without overwhelming yourself or committing a large amount of time or money to a course. Thank you.
Great, Marcus. And for the next question, maybe I'll get some insights from Tianbo and Ferris as well. This is a very interesting one. So based on what we have seen, what Ferris presented just now, and the online demonstrations coming up from GPT-4 Omni. So for the audience, if you have not looked at the demonstrations, the live demo, please Google GPT-4 Omni and check it out after this talk. You'll be mind blown. And why I say that is what GPT-4 or in general large language models can do now are becoming increasingly generalist, meaning they can do multiple tasks beyond medical domain. And so it's beyond your imagination. So with that in mind, given that it is becoming more and more generalist, if we bring that back to eye care, so does that mean moving forward in the future, we should have one AI that is one size fits all that can do everything? Or is there still a place to develop multiple models for different specific eye care tasks? So would like to hear your views on this, Ferris and Tiempo.
I'll let you start, Diambo. Maybe more from a technical perspective. Do you feel that's feasible?
Okay. So that's a very good question. This is my personal view on this. Yes, a lot of big models will be able to do tasks in different fields in the future. However, we still need some domain-specific module to handle, number one, different, very unique data set, such as OCT, or some kind of waveform data set or unique data set existing in, say, ophthalmology, but not in other field. That's number one. Number two, the task could be very different from different field. For example, if you do eye surgery, the actions, manipulation, or the intervention space will be very different from a heart surgery. So those module needs to be developed if you are building, say, a robot doing the surgery. And so I think it will be combination of generalist AI with specialist sub-modules in the future.
Yes, I totally agree with that approach. I think to me it's a bit unconceivable that maybe an ophthalmology lab has the same compute or the same money, the same capacities to build really good language models that are as good as, let's say, GPT-4 or Gemini or Claude. Because those companies, buy hundreds of thousands of GPUs and train their models. So, it goes back to my point. I think we should use those generalist LLMs, as agents to do a variety of things for us. And ideally, we would combine them, as Yambo said, with very specific modules that are domain specific and specialized.
Okay. Yeah. So here's another question. I think okay, let's take this one. So in general, of course, as what Ferris mentioned, the regulatory process takes very long to approve new AI technologies for actual use. So would you think that this may be causing problem in clinical practice, given the long process of approving new medical devices?
Yeah, I think at some point, if the regulatory agencies are not up to speed to the progress of science in AI, then we might actually be harming our patients by missed opportunities to help them. But it's a fine balance, I think, between progress and then safeguarding the patient.
Okay, yeah, and of course, here's an interesting question. So, uh, will the large language model or the doctor be responsible for the results? Well, this is an interesting one. Any takers on this? Perhaps Marcus?
I think in the current environment, really, it will remain under the purview of the attending doctor who is responsible for interpreting the LLM as well as the clinical status of the patient and the other investigations to finally give the patient, the diagnosis and management. It will be very far in the future if we ever see an LLM take on the task of assistant clinician. And actually, following on to that, I had a question for Faris. When you guys were talking about the generalist LLMs. So in your presentation, you went to benchmark the performance of one of the generalist VLMs in retinal disease. Did you expect this level of performance, this poor performance from a generalist VLM, or did it surprise you and your team?
It was a bit surprising because some anecdotal, interactions we've had with those models is, my first reaction is, I saw GPT-4 became multimodal. I put an open access OCT and I get a really impressive answer. And then I thought, okay, so maybe we're onto something. But there is a big difference between having, an open-ended, open text answer versus asking the model to give you very specific yes, no. And this is why we wanted to have a structured way of exporting those answers because they were easier to analyze and more objective. So the model might be able to confabulate and make it appear that they know what they're talking about, but when we tested it on saying yes, no for each feature, it didn't do well. One thing it did really well is recognizing that it was an OCT or a color fundus photo. So it recognizes the modality, but it doesn't reach expert level for feature detection, diagnosis, and management.
Great answer. I was just thinking back on what Tianpo had mentioned earlier about, these VLMs, these generalist VLMs being able to take in the nuances of an OCT interpretation when, they're trained on a whole vast other kind of literature and videos. These videos are not even, eye related. So I was thinking whether that could also contribute, to the poor performance. But yes, great answer. Thanks.
Yeah, Marcus, thanks very much. I think we have similar suspicions. Very likely that is the case. But who knows? With future fine tuning, maybe things will further improve. And actually, I have a question for Ferris. Now, given that you have experimented on different ways of doing prompting, zero shot, and the one that you showed just now. So, what is your general feeling now? Have you kind of narrowed down to a specific way of doing prompting to get the best version of responses from large language models?
To be honest, not yet, because it all depends on the context. If we're trying to, to have a model that responds to patient queries, then our data set that we use and that we use has to reflect how patients would ask questions, and they wouldn't expect patients to use elaborate prompts. But then, if we're trying to get the best possible responses, then we could use some chain of thought or reasoning, advanced reasoning prompts, and those can give us better results at the expense of cost, because those tokens as an input as an output typically are longer. So there is a fine balance, and it really depends what you're trying to achieve. If you're trying to compare, different models across different publications, you must use the same prompt. Otherwise, you're introducing so much confounding variables.
Yeah, totally agree. And not if let's say if it's for patient use, and normally patient will just be very layman, and very likely it's a zero shot type of prompting. And
Mhm.
the evaluations that we do, of course, we will try to be standardized, very research-like as much as possible. But at the same time, it needs to be real world enough. It needs to mimic real world scenarios enough as well. So if let's say with zero shot prompting, and that already gives a decent level of performance, that will be very encouraging. But of course, now we still see a gap, and it's not quite there yet, even though it looks very promising.
Yeah.
Tianpo and Marcus, maybe I'll open the floor to you guys for maybe last one or two comments.
Yeah, if you have tried OpenAI, sorry, the ChatGPT 4.0, you will realize some problem there. For example, if I give it a logo of OpenAI, ask the model to change the O in the OpenAI words to say a W or a U, it will actually change the whole picture. It's very different from previous one. So I think there is still some problem of, as Faris just mentioned, so there's some problem separating different objects or different parts of the visual view and only operate on a sparse subset of it. So I think there's still quite some room for improvement of the large language models.
Yeah, so I think we are right on time. Maybe let me close this by thanking Ferris once again. Thank you so much for the wonderful talk and great insights, as well as good insights from Marcus and Tianpo. It's been a wonderful discussion, very interactive, and great questions from our audience as well. And I would just like to say that we have close to 400 people joining us this evening, which is a huge turnout. And thanks very much again. This is indeed a very interesting topic, ever evolving, to be honest. And not just ever evolving, but super rapid. So how do we keep up? What I can say is, and just summarizing all experts' opinions here, we have to evaluate with a clear mind, and everything still needs to be guided by evidence. And as we have seen today from Farah's presentations, a lot of evidences, and it gives us good insights what it can do, what it can't, what's promising, what still needs to be further evaluated as well. So there's still a lot of work to be done in this space, and we welcome more and more people to join us in this research space as well. So Ferris, thank you again. Once again, thank you so much. And for all the audience out there, have a good night. And we look forward to seeing you in our monthly webinar next time in June. Thank you again.
Thank you so much. Thanks.